Good day, online classmates! Welcome to Pat TV. This is Quarter 1, Weeks 1 and 2 of Grade 8 Mathematics. Before we proceed to the lesson proper, please grab a pencil or ball pen and your notebook or paper for you to jot down notes. The objectives for this lesson are the following. Number 1, to familiarize with different types of polynomials. And number 2, to factor completely different types of polynomials. Let's get started. First, let's have a review of the greatest common factor or GCF. The GCF of two numbers is the largest number that divides evenly into both numbers. For instance, the GCF of 16 and 20 is 4 since it is the largest number that divides evenly into both. Another example, the GCF of 6, 12, and 24 is 6. Now let's proceed to factoring polynomials with common monomial factor. The GCF of polynomials work the same way. Just take note that for set of expression in the form x raised to n, the GCF will always be the expression with the lowest degree. For example, the GCF of x and x squared is x since x has the lowest degree. Another, for y cubed and y raised to 5, the GCF is y cubed since it has the lowest degree or exponent. Let us try factoring 16x plus 20x squared. In factoring this, let's follow these steps. Number 1, identify the GCF of the numerical coefficients. The coefficients are 16 and 20, and their GCF is 4. Number 2, identify the GCF of the variables. The GCF of x and x squared is x since x has the lowest degree or exponent. Number 3, combine to find the GCF of the expression. So let us combine 4 and x. So the GCF of the expression is 4x. Number 4, determine what the GCF needs to be multiplied by to obtain each term in the expression. To get 16x, 4x should be multiplied to 4, and to get 20x squared, 4x should be multiplied to 5x. So we have 4 and 5x. Number 5, write the factored expression as the product of the GCF and the sum of the terms we need to multiply by. So we have 4x as the first factor and 4 plus 5x as the second factor. Hence, we have 4x times 4 plus 5x. Another example, let us factor 2x squared plus 10x cubed. Identify the numerical coefficients first. We have 2 and 10, and their GCF is 2. Next, identify the GCF of the variables. The GCF of x squared and x cubed is x squared. And then we combine them to get 2x squared. Now, this is the GCF of the expression. For the fourth step, let us determine what the GCF needs to be multiplied by to obtain each term in the expression. So we have 1 and 5x. Lastly, we write the factored form of the expression. We have 2x squared multiplied to 1 plus 5x. Try this one. Factor 12x squared minus 20x. Let us check. The numerical coefficients are 12 and 20, and their GCF is 4. For the variables, x has the lowest degree. We combine to get 4x. And to get 12x squared minus 20x, we should multiply 4x to 3x and 5. Now we have the first and the second factors. We combine them. So we have 4x multiplied to 3x minus 5. Now let's proceed to factoring binomials. Factoring may require finding the GCF. Others can be factored using identities such as the following. First, we have difference of squares. The difference of squares appear in the form a squared minus b squared. So we have two squares and the minus symbol. And its factored form is a plus b multiplied to a minus b. Here are a few steps that we may follow. Number 1, confirm that the first and the last terms are perfect squares. So for a squared minus b squared, both terms are perfect squares. Their square roots are a and b respectively. Number 2, write the factored form. So we write it as a plus b multiplied to a minus b. Observe that we make use of the two square roots. Now let's have examples. We factor 4x squared minus 16. Number 1. Both 4x squared and 16 are perfect squares. The square root of 4x squared is 2x and the square root of 16 is 4. And then we write the factored form as a plus b multiplied to a minus b. So we get 2x plus 4 multiplied to 2x minus 4. Let's have another example. Factor x squared minus 25. Number 1. Both terms are perfect squares. The square root of x squared is x, and the square root of 25 is 5. Number 2, we write the factored form. So we have x plus 5 multiplied to x minus 5. Now it's your turn. Factor 9x squared minus 16. Let us check. Number 1, both terms are perfect squares. The square root of 9x squared is 3x, and the square root of 16 is 4. And then we write the factored form. So we have 3x plus 4 multiplied to 3x minus 4. Next is sum and difference of cubes. Let us illustrate this first. A cube plus b cube is an example of a sum of two cubes since both terms are cubes and the operation is addition. A cube minus b cube. This is an example of a difference of two cubes since both terms are cubes and the operation is subtraction. For binomials in the form a cube plus b cube, the answer is in the form a plus b multiplied to a squared minus ab plus b squared. While for binomials in the form a cube minus b cube, the answer is in the form a minus b multiplied to a squared plus ab plus b squared. For example, let us factor 8x cubed minus 125. Take note of these observations. Number 1, both terms are perfect cubes. The cube root of 8x cubed is 2x, and the cube root of 125 is 5. With this example, a equals 2x and b equals 5. After that, we write the factored form in the form a minus b multiplied to a squared plus ab plus b squared. Let us substitute and perform the necessary operations. Hence, we get 2x minus 5 multiplied to 4x squared plus 10x plus 25. This will be our final answer. Another, let us factor x cubed plus 512. Number 1, both terms are perfect cubes. The cube root of x cubed is x, and the cube root of 512 is 8. With this example, a equals x and b equals 8. Number 2, write the factored form in the form a plus b multiplied to a squared minus ab plus b squared. Let us substitute and perform the necessary operations. Hence, we get x plus 8 multiplied to x squared minus 8x plus 64. Try this. Factor x cubed plus 27. Let us check. Both terms are perfect cubes. The cube root of x cubed is x, and the cube root of 27 is 3. With this example, a is equal to x and b is equal to 3. And then we write the factored form. Let us do substitution and perform the necessary operations. Hence, we get x plus 3 multiplied to x squared minus 3x plus 9. Factoring perfect square trinomials. A perfect square trinomial is a trinomial that can be written as a square of a binomial. Examples: a squared plus 2ab plus b squared can be written as a plus b squared, while a squared minus 2ab plus b squared can be written as a minus b squared. Here are some steps that we can use. Number 1, confirm that the first and last terms are perfect squares. A squared and b squared are perfect squares with square roots a and b respectively. Number 2, confirm that the middle term is twice the product of a and b. In the example, we have 2ab. And number 3, write the factored form as a plus b squared or a minus b squared. For example, factor 25x squared plus 20x plus 4. Number 1, the first and last terms are perfect squares. The square root of 25x squared is 5x and the square root of 4 is 2. Second, let us confirm the middle term. 2 times 5x times 2 equals 20x, which is true. If this is confirmed, then we proceed to step number 3. We write the factored form. So we have 5x plus 2 squared. Another example, factor 9x squared minus 24x plus 16. Number 1, the first and last terms are perfect squares. The square root of 9x squared is 3x, and the square root of 16 is 4. Number 2, let us confirm the middle term, twice. So we have 2 times 3x times 4 equals 24x, which is true. If this is confirmed, then we write the factored form. So we have 3x plus 4 squared. That is our final answer. Now you try this. Factor x squared plus 2xy plus y squared. Let us check. The first and last terms are perfect squares. The square root of x squared is x, and the square root of y squared is y. Now we confirm the middle term. 2 times x times y equals 2xy, which is true. If this is confirmed, then we write the factored form. So we have x plus y squared. Factoring general trinomials. In general trinomials, we can encounter trinomials that are not perfect squares. We can use these steps in factoring 1. First, we set up a product of binomials. Write 2 empty parentheses that will be filled with 2 binomials that are equivalent to the original equation. Number 2, we write values for the first term in each binomial such that the product of the values is equal to the first term of the expression being factored. Number 3, find a product of 2 values that is equal to the third term in the expression being factored that when added equals the coefficient of the second term in the equation. Write each value as the second term in each binomial with the appropriate sign. Let us analyze this example. X squared plus 3x minus 28. First, we write 2 parentheses. Next, we identify the first term, which is x squared. So what will be the factors of x squared? So we have x, and then we think of 2 numbers that if we multiply, we will get negative 28, and if we add, we will get 3. So we have 7 and negative 4. Another example. We factor x squared minus 5x plus 6. For the solution, we draw first 2 parentheses, and then we identify the first term, which is x squared. So what are the factors of x squared? We have x, and then we identify the last term, which is 6. We think of 2 numbers that if we multiply, we will get positive 6, and if we add, we will get negative 5. So we have negative 3 and negative 2, and that will be our final answer. Now you try this. Factor x squared plus x minus 12. Let us check our solution. So we draw 2 parentheses. We identify the first term and factor it. And then we think of 2 numbers that if we multiply, we will get negative 12. And if we add, we will get positive 1 or just x. So we have x plus 4 and x minus 3. That will be our final answer. And that ends our lesson for this week. See you again next time. Thanks for watching.